Good day, viewers, and welcome to your best learning hub for the sciences, Jalo Science Academy. I am Mohammed Jalo, and in this tutorial, I'll be taking you through your oxidation reduction reactions, which we often refer to as redox reactions. Because redox reactions are complementary processes, because whenever oxidation takes place, then reduction will also take place. But then, what is redox reactions? We are going to look at it from three different perspectives. One, under the concept of oxygen or hydrogen transfer, and two will be under the concept of electron transfer, and the third one will be under the concept of oxidation numbers. So let's start with in terms of oxygen and hydrogen transfer. In terms of oxygen and hydrogen transfer, we can define oxidation. We're going to start with oxidation. Oxidation is defined as the addition of oxygen or the removal of hydrogen. So if oxygen is added to a chemical species or hydrogen being removed from a chemical species, then that reaction we can refer to it as an oxidation reaction. Let's look at an example here. Say, for example, we want to look at the addition of oxygen. Let's look at in a situation of the rusting of iron or the burning of carbon in the presence of oxygen. So rusting of iron Fe, solid, if react with oxygen, gaseous, in the presence of moisture and this gas, it is going to form Fe2O3. This is known as iron rust. Okay, so in this case, so oxygen being added to iron to give us the iron trioxide. Okay, so this is what you have in this case. So the addition of oxygen is known as oxidation. Or let's look at another example here. We can also look at the burning of carbon in the presence of oxygen gas. So when this burns, it is going to produce what? Carbon dioxide. So this is also an example of the addition of oxygen. But we said it can be either the addition of oxygen or the removal of hydrogen. So let's look at a situation wherein hydrogen is being removed. These are examples in the case wherein oxygen is being added. So the third one here, let's say for example, we are going to react two gases, that is hydrogen sulfide gas and chlorine gas. This kind of reactions, we refer to them as a precipitation reaction, wherein two gases are going to react to give you a solid substance. So what's going to happen in this case? The hydrogen is going to be chemically removed from this hydrogen sulfide by the chlorine. Okay, so what happens? We are going to get solid sulfur, a yellowish substance is going to be formed, and then the hydrogen now reacts with the chlorine, HCl. So we can balance this equation by placing 2 here. So this HCl that is formed is also gaseous. Okay, so you have hydrogen sulfide reacting with chlorine to precipitate sulfur and then hydrogen chloride gas. So in this case, we find out that what hydrogen has been chemically removed from the hydrogen sulfide. So this is for oxidation. Now let's look at reduction. But one thing you should note is oxidation and reduction are always opposite, even though they are complementary, but they are opposite. Okay, if oxidation involves the addition of oxygen and removal of hydrogen from a chemical species, I mean reduction is going to be the reverse. So reduction will now be the addition of hydrogen or the removal of oxygen. So the addition of hydrogen or the removal of oxygen from a chemical species is known as reduction. Let's look at examples. So we begin with the addition of hydrogen. Let's say here Cl, chlorine gas, reacts with hydrogen sulfide, gaseous also. So in this case, what happens? Hydrogen is going to be added to the chlorine. When hydrogen is added to this chlorine, and then it is going to form HCl. So we say here, chlorine have reduced because hydrogen from the hydrogen sulfide has been added to the chlorine, making the chlorine to reduce. And then you have ordinary sulfur that will remain. Okay, so this here can be balanced by just placing 2 in front of this. This is for the addition of hydrogen. So let's look at the next example under the removal of oxygen. So we can have copper oxide, a solid, reacting with hydrogen gas. So what is going to happen here? Hydrogen is going to remove this oxygen from the copper, leaving behind a metallic copper, and then the oxygen is going to combine with the hydrogen to give us water. Okay, so this is an example of the removal of oxygen from a chemical substance. Okay, we can also look at another example. Example 3, let's say we react iron oxide and charcoal. Iron oxide, that is Fe2O3. So this is a solid substance. If reacted with charcoal carbon, also solid, what happens? Carbon is going to remove the oxygen from the iron. So we say iron here have reduced by losing the oxygen, and then it is going to combine with the carbon to give us carbon dioxide. So we can balance this equation here. Of course, here we have 3 atoms of oxygen. So we place 3 here. This becomes 6. So we can place 2 in front of this. By placing 2, iron becomes 4. And then we place 4 here. And we place 3 in front of this. So this becomes our balanced chemical equation. So this is for the concept of oxygen and hydrogen transfer. Now let's look at it under the concept of electron transfer. Now, in terms of electron transfer, oxidation can be referred to as the loss of electron. The loss of a electron or electrons is referred to as oxidation. Okay, let's look at some examples here. You have sodium, metallic sodium, losing an electron to become Na plus, aqueous. So we say here this sodium have oxidized. Or let's say we have calcium, solid, losing 2 electrons to become Ca2 plus, aqueous. Then we say this is also an oxidation process. Okay, or you have aluminum, solid, losing 3 electrons to become Al3 plus, aqueous. This is also an example of an oxidation process. But let's say we have the chloride ions, chlorine ion here, losing, let's say it is 2 of them, losing 2 electrons to become the chlorine molecule gaseous. So this is also an oxidation process. So oxidation simply means the loss of electrons, and we can memorize it by memorizing this word oil, meaning oxidation is loss. This O represents oxidation, and this I represent is, and the L there represents loss. So we say oxidation is loss. And what is lost? It is electrons that are lost. So we say oxidation is the loss of electrons. I told you earlier that if you have this for oxidation, then to get for reduction, you are going to take the reverse process, meaning reduction is going to be the gain of electrons. So reduction we say is the gain of electron. So the gain of electron or electrons is reduction. Let's look at examples. Chlorine here, Cl, will gain an electron to become Cl minus. Okay, so in this case, we have electrons being gained, chlorine gaining one electron. Second example, we can look at the oxygen atom gaining two electrons to become the oxide ion. We can also say, we look at the nitrogen atom gaining three electrons to become the nitride ion. The negative charge here tells you they've gained an electron. The positive charge tells you they've lost electrons. Okay, so negative charge meaning gain of a electron or a electrons, and the magnitude of the charge tells you the number of electrons that have been gained, whereas for the positive charge, the magnitude of it tells you the number of electrons being lost. So if you see minus, it means one electron being gained. Minus 2 means two electrons being gained. Minus 3, 3 electrons being gained. Plus 1, an electron being lost. Plus 2, 2 electrons lost. Plus 3, 3 electrons lost. Or we can look at the fourth example here. Let's say, for example, we have the sodium ion here, aqueous, gaining an electron to become the sodium atom. This is also a reduction process, okay? And the reduction, we can memorize it by this word Reg. R represents the reduction, the I here represents the is, and the G represents gain. And what have been gained? It is electron or electrons that are being gained. Okay, so plain and simple for you to learn this, just memorize oil rig. Oxidation is loss, reduction is gain. And there are a few things also that you have to note when you look at these half equations. When electrons are written on the left and also when they are written on the right. Now, if you have a electron or electrons being written on the left hand side, that tells you those electrons are gained electrons. For example, for the reduction process, all the electrons are written on the left hand side of the half equation, and then on the right, if they are written there, that tells you they are lost electrons. As we saw in the examples for the oxidation, all the electrons were written on the right hand side of the half equation. So this is something that you have to note. And also you should note when a species gains a electron, the charge is going to decrease. So for gain a electron, you have a decrease in the charge. Okay, and for lost electrons, you are going to get an increase in the charge. So you also have to note these small things. Okay, I told you earlier that oxidation and reduction processes are complementary, meaning we can have in one equation oxidation taking place, and in that same equation reduction taking place. Let's look at a few examples. So first example we are going to look at is the combustion of sodium in an atmosphere of chlorine. Sodium here, Na, solid, being burnt in the presence of chlorine gas. So what is going to be produced? You get sodium chloride that will be produced. Okay, you get sodium chloride that's going to be formed, and we can balance this by placing 2 here, and we place 2 in front of this. Now, this is a process wherein oxidation is taking place and reduction is taking place. You know, sodium chloride is an ionic compound with sodium having a charge of +1 and chlorine having a charge of -1. This guy here has got no charge and this has got no charge. So if we try to look at the processes taking place here, we can tie these two together. Okay, you see here sodium and this, so the charge has what? Increased. I told you of increase in charge and then decrease in charge. And if we look at the chlorine here, it has decreased from 0 to -1, and these have increased from 0 to +1. So that tells us because the charge of sodium have increased, sodium have lost electrons. So in this case, sodium is undergoing oxidation. We can write it down by saying Na became Na plus. Of course, you have 2 atoms of sodium here. So each atom is going to lose an electron. So 2 atoms of sodium will produce 2 ions of sodium after losing 2 electrons. So this one tells us that electrons are lost, because I said if electrons are written on the right, that tells you they are lost electrons. Next, we look at the reduction process. You have chlorine gas here that is going to gain 2 electrons, because this tells you it is a molecule. You have 2 atoms of chlorine in there, so each one is going to gain an electron, making it a total of 2 electrons gained, and it is going to produce 2 chloride ions, aqueous. These aqueous and this solid. So when electrons are written on the left hand side, that tells you it is gain, and then the charge also decreasing. So this is a process we refer to as a complementary process. So meaning oxidation is taking place and reduction is taking place. So for this reason, we refer to these reactions as redox reaction, because you have both oxidation and reduction taking place. So the next example we are going to look at is reacting 2 gaseous substances, that's hydrogen sulfide and chlorine gas. Example 2, hydrogen sulfide These 2 gases will precipitate sulfur and give us hydrogen chloride gas. So now if we want to balance this equation, we can just place 2 in front of this. Now we want to see how actually reduction is taking place here or oxidation is taking place. Of course, if you look here, you will discover that hydrogen is a spectator, because hydrogen always has a charge of +1, okay, except in metallic hydrides, where we have to get there. So here, hydrogen and hydrogen will cancel. So we can write this as an ionic equation, writing it as sulfide ion, S2- reacting with chlorine to give us sulfur, and then the chloride ions, 2 chloride ions here. So this is what we have. This is the ionic equation, because hydrogen is a spectator. Spectators are species whose oxidation number does not change. So we refer to it as a spectator ion. Okay, hydrogen is a spectator ion in this case. So now we want to see how the reduction and oxidation process are taking place. This guy has a charge of +2. This one -2 rather. This one has no charge, and this guy has no charge. This one has a charge of -. So we can say here the sulfide ion has been oxidized into sulfur, and the chlorine molecule been reduced into chloride ions. You can see the charge here is -2, the charge here is 0. That is, the charge have increased because 0 is bigger than all negative numbers. Here the charge is 0, and the charge here -1 by these 2 gives us -2. So the charge have decreased. So we can write these equations independently, write the oxidation half and the reduction half. The oxidation half will be this. Now, this guy here has increased in charge. So we say the sulfide ion became sulfur after losing 2 electrons. Okay, so this is the oxidation process. And we can write the reduction as this. The reduction here means the chlorine molecule Cl2, because you have 2 atoms of chlorine in this. Each one gains an electron, and then you have 2 electrons in total gained to give us 2 chloride ions. Okay, so this is also a complementary process because oxidation is taking place there and reduction is also taking place. So next we look at oxidizing and reducing agents.